Okay, so, I just very quickly review the, let me see if don't want to, maybe, I shouldn't turn on the camera. So where's don't have my, okay, here's the pen. Yeah, so this is like the time value. So what is time value? Okay, so to put it, in a very simple example, if I offer you either 6,000 or 6,500, which one will you choose? Okay, of course, everybody will say, oh, 6,500. But what if I say I offer you 6,000 today and then 6,500 in 2 years? What will you choose? Okay, so so that's the questions that we should try to figure out. Actually, let me do a really quick poll, see what you guys would choose. Okay, let's see. Present value. Question one. Cash. 6,000 today or 6,500 in 2 years. Let me just talk away. Okay, so you should be able to see the pool just in few seconds, really quick, select your answer. What would you rather get 6,500 in 2 years or 6,000 today, now? Okay, so so actually we have 63% choose they want 6,000 today, and then 38% they want 6,500 in 2 years. So I'm guessing the one that want 6,500 in 2 years is they're worried I might spend it today. But the correct answer should be 6,000 today, because 6,500 in 2 years, if with the 6,000 today, with the interest rate we have now, you should be able to make maybe more than 500 in 2 years. Okay, especially like if you invest in a stock market, maybe you get even more. Okay, so that's why in theory we should we should calculate the net present value. Okay, so the net present value is in 2 years, how much would a 6,500 be? How much would it be worth today? Okay, so so that's why we are using this. Okay, you are using these slides to explain what exactly is net present value. So the present value is the value today of a future cash flow. Like this example, in 2 years, you will get 6,500. Okay. And the future value is if you invest today, how much would it be in 2 years? Okay. So we have the present value or future value. So when we compare the money value, we need to make sure it's either both in present value or both in future value. Okay. But we usually like to calculate when we talk about investment, how much you want to invest. Usually we want to look at the present value. So this is the future value of $100 equal, FV. So what is the future value of $100? So it will be, depending on how you are going to invest, right? So, wait, oops. Okay. didn't show up. So it's, let me see. Yeah. So it's a $100. It depending on, you know, what is your rate. So in this example, if your interest rate is 7%, so in 2 years, it will be it didn't pop up. Let's see what I can do. Well, this is because I have MacBook. Let me try to escape. I don't even know how to escape from MacBook. Okay, here. Just a second, okay? Sorry. Let me stop share. Let me see if I can get the sorry, I got question. Okay. So let me see if I can get, okay, PowerPoint. And then to open the file that I just have. Okay, so this is better. Sorry about that. I thought, did I? Sure. Yeah. Okay. Let me share screen again. Here. So this is the PowerPoint. It's not the Windows, the Apple stuff. Yeah. So this is the future value 100 times, you know, depending on when you're going to have it. Like the previous example will be 6,000 times 1 plus the current, you know, whatever rate to the power of 2. Okay. So this example is, so what is the future value of $100 if the interest is compounded annually at the rate of 7% for 2 years? So if I get my pen, so it'd be 100 times 1 plus 0.07 to the power, sorry, I'm using the mouse, to the power of 2. Okay, so that would be the future value of this example. Okay. Yeah, so this is how it will be calculated. 114.49. So the the future value with compounding, like it's 1 plus r to the power of t, you know, how many years. So with that, we see the compounding interest rates power. Okay, you see like for the compounding rate as 15. Okay. It actually, we can double the money in the very short period of time. Okay. So, you know, like in this case, in 20 years, you can make a 15%, 16 times. Okay. 16 times. Yeah. 1600 compared to 100. Okay. So that's the compounding interest rate. And the present value is like the opposite of the future value. So we see the how we calculate the future value, right? So if we can say that if we think after 5 years we open a store, we will start to make, let's say, $1 million, then you know we can calculate that $1 million in 5 years. 5 years we'll have $1 million and then calculate it back to the present value, okay? So we have the discount factor divided by the rate of return plus 1 to the power of t. So that's our present value. So present value, we can use the future value, okay? In this case, it's 114.49 divided by 1 plus 0.07 to the power of 2. So when you calculate it back, the present value will be $100. Okay, so if you look at, so that's like the opposite of the chart we show you. Okay, so for the present value of $100, depends on how many years. You know, if it's 20 years, then the present value is actually like a little bit less than $10. Okay, so it's similar to, you know, how we calculate it, but we just calculate it back. So one example is, if we expect, if we want to invest in this, you know, building, the cost of the building is $700,000. Okay, and we think we can sell it in 1 year for $800,000. And like now, the rate of return is 7%. Okay, so when we convert the $800,000 in 1 year back to present value, 7%. So 800,000 divided by 1.07. Okay, because to the power of 1, just 1 year. Then we get $747,664. So the net present value is this number we will get in the future in 1 year, minus whatever we are going to put in today. So we actually make $47,664 in 1 year. Okay. So it's actually not bad, right? But if you look at, yeah, so that's, you know, as long as it's positive, then, you know, probably would want to make that investment. So the net present value is the present value minus the required investment. But the higher risk we have, usually it will require higher rate of return. And the higher rate of return, it would make the present value lower. Okay. So this case, the rate of return is 7%. But what if, you know, think, oh, this project is very risky. So what if the rate now is 12%? Then the present value become 714,286. So instead of making 47 something thousand, we are only making $40,000 with the investment of 800,000. Okay. So if it's risky, then the present value will be lower. The net present value will be definitely be lower. So if the rate is going to 14, then this number will probably be less than 700,000. So they will make net present value to be negative. So in that case, we won't want to invest. Okay, so this is still positive. So maybe we still would invest. So usually when we have a positive net present value, we will try to invest. But in some case, it depends on how much fund we have, you know, might be able to prioritize. Yeah. So if it's 10%, then we make $27,000. So usually we will accept the investment that offer rate of return higher than the cost. So we will have a positive net present value. Then we will invest. Yeah. So to calculate sort of like the break-even point, okay, we can use 800,000 minus 700,000 divided by 700,000. So we know the rate of return, if it's over 14.3%, then our rate of return will be negative. I mean, our net present value will be negative, right? So in that case, we won't make the investment. And then we also have different multiple cash flows, like what we are going to do in our Excel example. So the Excel example, well, we will talk about it later, but the present value, current present value, 0 means now, okay, 0 period, is from year 1. So C1 is year 1, the cash flow, C1, divided by the rate 1 plus R to the power of 1. And then plus year 2, in year 2, what we will get, the cash flow discounted back to 2 periods of time, okay? Until CT divided by 1 plus R to the power of T. So the net present value is the C0, usually it's negative, right? It's our investment, plus all these future inflow, okay? The sum of the future inflow, discounted back the present value. So if we're going to invest something for $700,000, the first year, we only get $30,000 back. The second year, we get $870,000 back. So if we calculate it to the present value, the first first year, $30,000, when we convert it back to now, it will be $26,786. And then second year, $870,000 divided by 1.12 to the power of 2 is 693,559. So when we add this together, minus our investment, we make about $20,344. So that's the net present value. And sometimes there are shortcuts to make it easy to calculate the present value. If it pay off in different period. So if you have a financial calculator, sometimes they just let you do input. You can input your future cash flow, and then they will just calculate the net present value for you. Yeah. So, and then this is the same, what is it? Same formula, but we just kind of change it to, so let me use this. So it was the present value equal to C divided by R, right? So now we just kind of convert R with the P present value. Yeah. So that's that. So that's a perpetuity. If we are going to get money forever, so that our return is the cash flow divided by present value. So the present value for perpetuity is the present value equals C divided by R. Okay. So this is, oh, oops, okay, it works. So this is the present value of cash flow divided by discount rate, R. So that's the perpetuity, which we would kind of use in our kale and kombucha case. So present value of $1 billion every year for eternity, that would be nice, right? If you estimate the perpetual discount rate to be 10%. So it would be 1 billion divided by 0.1. So that means the present value is $10 billion. Even though, we can get it every year till, infinity, but the present value is actually only 10 billion because, let's say maybe in 20 years, we get $20 billion, but the $20 billion might only worth, you know, certain amount of money. It might not be worth, it would definitely worse than less than $1 billion, right? So, so that's why, you know, when we use this to calculate the present value of perpetuity, it's 1 divided by the 1 billion divided by the rate, which is 10%, 0.1. Okay, so that's the present value. What about, you know, we won't get the money until 3 years from now. Okay, so then we kind of discount it because we will count. Let me see if I can get a pen. Yeah, so this is 0, 1, 2, 3. So we get the $10 billion now, right? I mean, not now, in 3 years. So we have to discount this money back to this, okay? So this is $10 billion. And now we have to discount it back. So discounted, you know, 1.1 to the power of 3, discount it back to now. So it would be actually $7.51 billion, okay? Does it make sense? I hope it does. So, come on, okay. So annuity, we use the concept we just talked about, okay? So annuity is the cash flow times 1 over R minus 1 over R times 1 plus R to the power of T. So what does that mean is, how should I put it? Let me see. So we will get money, right? So annuity is we get money for certain numbers of years. And so we use the perpetuity. So let me put it this way. 0 to 20. And then this is like forever, okay? So this part is here, is C divided by R, right? And then, yeah. And then this one is R, and then C, okay, C divided by R, and then divided by 1 plus R to the power of T. So that means this is, we calculate the value from here to here, okay? So the perpetuity here. So the first part is here to here. And then the second part is here to here. So by using this minus this, we'll get this value. This is the annuity. So from year 0 to 20. So I mean, in assuming T equal to 20, this is a 20-year annuity. Okay, so that's that. So that's how we calculate annuity. Yeah. Okay. So the present value of annuity factor, you know, like we just talked about, use that. Okay. So, so see that they tell you. So perpetuity, first payment in year 1. Okay, in year 1. And then, you know, perpetuity. So the present value is CR. And then perpetuity, the first payment in year T plus 1. So T plus 1 here, from here. This is that. So the annuity from year 1 to T is this minus this be here. Yeah. I just drew it and I forgot. It's on the next slide. So the Tiburon Auto offered the easy payment, $5,000 per year at the end of each year for 5 years. Interest rate is 7%. What is the cost of the car? So this is year now. This is now year 0. So year 1, you pay $5,000. discounted back by 7%. So now it's 46.73. Year two, you use this, it's 43.67. Year three, you pay 5,000. This is present value, 4 and 5. So when you add it up, the car present value is 20,501. Okay. So if is it worth it? We don't know. Yeah. So that's that. And then the state lottery, they advertise jackpot price $590.5 million. Pay 30 installment over 30 years of 19.63683 million. At the end of each year, the interest rate is at the end of each year, the interest rate is 3.6. What is the true value of the lottery price? So the lottery value is, so the value every year we get 19.683, okay, for 30 years. So 19.683. Yeah. So the first one is perpetuity, and then second one is the 30 years now. So the value of that is actually $357.5 million. But the jackpot price is excuse me. Oh my goodness. It's $590.5 million. My cats were fighting in the back. And then I turned over, looked, and I saw some black fur was floating in the air. So, and then the annuity example, you are purchasing a TV for $1,000 and scheduled to make 4 payments. So each one, so the rate is now, let's say 10%. What is the annual payment? So it will be 100 equal to the payment, okay, the annuity times 1 over 10% minus 1 over 10% times 4 payments, 1.1 to the power of 4. Okay, so your payment is 315.47. Future value. Instead of using this, we kind of convert it. So it will be 1 plus r to the power of t minus 1 divided by r. So future of annuity, let's say $20,000 pay at the end of each of the following 5 years. What is the investors, and then the future value of $20,000 pay at the end of each year for 5 years, and the investment return is 8%. Okay, so it's 20 times 1 plus 1.08 to the power of 5 minus 1. So that's the rate of return for 5 years, but divided by 0.08. So that's actually $117,332 for future value. And this is another thing, the constant growth perpetuity. So it's actually in our kombucha examples. So we'll talk about it later. But if we have a constant cash flow, C1, and perpetuity, and then our rate of return is R, and then we expect the cash flow will grow from C1, every year it will grow at the rate of G. So the present value to calculate that cash flow will be C1 divided by R minus G. Okay, so this. So that means the rate of return, let's say the rate of return is 10%, and if the growth rate is 2%, so it will be, instead of divided by 0.1, it will be divided by 0.08 to kind of calculate the growth rate into here. So now the denominator is smaller, so that the present value will be bigger because, we're growing the cash flow every year constantly. Yeah, so example here is the $1 billion we were going to have. So if the rate of return instead of 1 billion every year, now it's actually every year it will grow 4%. So instead of using 1 divided by 0.1, we use 1 divided by 0.1 minus 0.04. So it will be 6%. So the present value would be a little bit higher, $16.67 billion. Okay. So effective interest rate is how we calculate like the APR, how we convert APR to effective the APR. Okay, so EAR and APR. So EAR is 1 plus the MR, the monthly rate, to the power of 12 minus 1. And APR is just the MR times 12. Okay, so we can just convert the APR to divided by 12, it will be our MR. And then EAR will be after we divide APR by 12, plus 1 to the power of 12. That will be the EAR. Okay. So this one. So if the monthly rate is 1%, the APR will be 12%, right? Times 12. The effective annual rate will be 1 plus 0.1 to the power of 12 minus 1. So this one will be 1 plus 0.1, 1.01 to the power of 12 minus 1. So it'll be like 12.68%, but APR is 0.01 times 12. I think I talked a little bit too fast, but this is the review of the net present value. So I'm going to, oh wait, somebody. Oh, thank you, Vincent. So Vincent posts a financial calculator. Yeah, so there are several financial calculator, and it actually so now the the physical financial calculator is 30 to 40 bucks. I remember when I was preparing the CFA when I was younger, it was almost $200. The HP something, yeah, the HP calculator.
Yeah, for the BA2 for Texas Instruments, I remember 2 semesters ago they're going like over $100, but I don't know what happened on Amazon. It's on sale for 30.
Nice. Yeah, because when I think the one I was going, when I don't know if still the case because I haven't touched, finance for a while. But when I was doing MBA, I was majoring in finance and I was, doing the CFA. For CFA exam, they only allow 2 types of calculator. And at that time, I think it's a HP. Is it HP? I think so. It was almost $200, almost 20 years ago. And yeah, so I don't know if they still use the same, but it was really fancy. And it's like, it's not the same logic as the normal calculator. I remember it took me a while to understand that, to learn how to use that calculator. But it was really good. Like, they can calculate when you calculate annuity, sometimes you get the payment in the beginning of the period, and in the end of the period, it will actually make a difference in your present value. So now you say it's like what, 30 to 40 bucks? Yeah, so and then I actually download the financial calculator on my Apple because I found it, so I thought, oh, it's interesting. So if you are really interested in this, you should try to get a financial calculator because it would definitely help. Or you can be like me, like try to calculate everything on your mind, on your head. So let me stop the recording so that we can have a smaller what is it? How do you say that? A video, okay? And then